Hello, math students. Mr. B here with the third and final video of our fraction review. All right, if you recall in video 1, we looked at multiplication and division of fractions and found that to be pretty simple. We didn't need a common denominator or anything. In this video, we're going to look at adding or subtracting fractions, which does require a common denominator. So to do adding or subtracting, we need a common denominator. Common denominator. So if we just have some generic fractions like a over c plus b over c, we see that the denominators are the same. We have a common denominator. In this case, it's a simple matter of just adding the numerators and keeping the same denominator. You do not add the denominators. That's a common mistake, to add the denominators. You just keep the same denominator. All right, and if you're subtracting, let's say we've got a over c minus b over c, so same fractions but subtraction. We're going to subtract the numerators and keep the denominator. Let's do a quick example of this with some real live numbers. How about 5/8 plus 2/8? We see that the denominators are common. We have a common denominator of 8. It's the same. So we simply add the numerators, 5 plus 2, keep the denominator at 8, and our answer is 7/8. And it's nice to see this graphically, really easy to see what's going on here. Let's say this number line is going from 0 to 1, and I'm going to break this up into 8 equal pieces because we have 8s, right? And we basically have 5/8. 1, 2, 3, 4, 5/8. So I've shaded 5/8 of the number line there. And then maybe in red, I'll shade another couple, another 2/8. And we see that we're at 7/8. All right. Let's do the subtraction of the same fractions. So what were they? 5/8 and 2/8? Let's take 5/8 and subtract 2/8. So in this case, we subtract the numerators, 5 minus 2, keep the denominator as it is, 5/8, 8, and the numerator is going to be 5 minus 2 is 3, denominator 8, so 3/8. Graphically, let's do the same sort of thing. We'll divide up 0 to 1 into 8s, 0, 1. So we start with 5/8, 3, 4, 5. I think I've got 5 there. Yep. And maybe I'll cross out the 2/8 that we're subtracting. And where are we? Well, 3/8. Okay, so I hope you see this as pretty simple if the denominators are the same. Okay, let's switch gears, and now we're going to add or subtract fractions that don't have a common denominator. That don't have a common denominator. All right, so let's try 5/8 plus 1/6. All right? Now, first of all, I want you to notice something. I'm going to do this problem in maybe not the best way, but a way that might give you some insight into what we're trying to accomplish here. What if we take 5/8 and we multiply 5/8 by 6 over 6? So you recall getting equivalent fractions, right? Where you multiply by something over itself, right? And you get an equivalent fraction. So what are we going to get here? Certainly the denominator, 8 times 6 is 48. And the trick is to multiply the 1 over 6 by 8 over 8, the other denominator. Can you see that the denominators have to be the same? So I'm multiplying one denominator by the other denominator. 6 times 8 is the same as 8 times 6. We're going to get the same denominator. What equivalent fractions do we get? Well, 5 times 6 is 30 for the numerator there, and 1 times 8 is 8. So we see that 5/8 plus 1/6 could equal 30 over 48 plus 8 over 48. So we have a common denominator, 48. We add the numerators, 30 plus 8 is 38, and the denominator is 48. We keep the same denominator. The only issue now is that this isn't fully reduced. We've got to reduce, we've got to simplify our answer. We always want a simplified answer. So 38 over 48. If we get the prime factors of the numerator and denominator, the numerator is going to be 2 times 19, and the denominator is going to be four 2's and a 3 if you use a factor tree. And we'll see we've got a 2 and a 2 on top and bottom. Those are going to go away. That's 1. And that leaves us with 19 over, what, 2 times 2 times 2 is 8. 8 times 3 is 24. So the final answer is 19/24. All right? So it took a little bit of work because we had to simplify. But it was easy to get the common denominator by just multiplying one denominator by the other one. The thing is, when the denominators are kind of large, this can get really messy, really messy. There's a better way. What is the better way? Let's just go to another page here. So, better way. And the better way is to find equivalent fractions with denominator equal to the least common multiple, sometimes called the LCM, of the denominators, of the given denominators. And this new denominator is often called the least common denominator. Least common denominator. You might have heard that term before. Least common denominator, or sometimes abbreviated as LCD. Okay? So let's do the same problem we just did before and see how we might do this. How do you find this LCM or LCD? It's really pretty easy. I'll give you two methods that you can use to do it. So let's say our fractions are still 5/8 plus 1/6. The first thing to do to find the LCM of those denominators, 8 and 6, is, let's see what we're doing here. Find the LCM of 8 and 6. So first you get the prime factors for each number. And here are the rules for finding the LCM. So it's like asking a question. In which list does each prime factor occur the most times? And you circle them. So let's look at these lists. Okay, there's two lists. You can have more than two numbers, but in this case, there's two numbers, two lists. And the factors we see are 2's and 3's, right, in these lists. So for 2, which list has the most 2's? The first list, of course, it has 3 2's. Which list has the most 3's? Well, the second list. It has 1 3. The first list doesn't even have one. If there's a tie, let's say that for some reason the list had 3 2's in one list and there were 3 2's in the other list, you just circle one group of 3. So let's put that down here. If tied, circle one group. All right. So I haven't shown that case, but you can imagine that happening. All right, so what is the LCM? The LCM is just the product of the numbers in the circles. So it's 2 times 2 times 2 times 3. So those numbers and that number there. And what do you get? 24? 24. This is also equal to the least common denominator. All right. I'm going to give you one more way to find the LCM. So another way, it's called a stack diagram. That's what I call them anyway. Stack diagram. So you start the same way. We've got 8 and 6, and you're going to write the prime factors, but you're going to write them in a way that you get these stacks. So what's the deal here? You stack where you can, and you never mix the prime numbers. So I can't put a 3 with a 2. It has to just be 2's. If you can stack them, you stack them. If there aren't extra 2's, you just leave them blank, right? And so forth. So we'll say stack same numbers where possible, and don't mix the numbers in a stack. Don't mix the numbers in a stack. Then what do? Well, you just look at each column you get. You use every single column, the numbers in every single column. We have a 2, a 2, a 2, and a 3. And that equals the 24, which is the LCM, and in this case, the LCD. So that's another way to do it with a stack diagram. I think it's easier to see, but I think the other way is a little quicker. Okay, so choose your method. Okay, all we have to do now is show how nice this is to use 24 as the common denominator for the equivalent fractions we're looking for. So we had 5/8 plus 1/6, and we'd like to get 5/8 into a new fraction, equivalent fraction with 24 as the denominator, and we like to do the same thing with 1/6. We want to get that with a denominator of 24. So what's going on here? 8 times what gives 24? I think it's 3, right? 5 times 3, we have to put 3's on the top and bottom here. The numerator for this one's going to be 15. 6 times what is 24? That's 4. We put it in the top and the bottom. 1 times 4 to get the new numerator. So 5/8 plus 1/6 is going to be 15 24ths plus 4 24ths, which is 19 24ths. And you can see that the answer didn't need to be simplified in this case. Now, I'm not guaranteeing that if you use this method that you'll never have to simplify, but the simplification will be a lot less. Now, why does this work? Why does this work? One thing I didn't tell you about the least common multiple is that that number is the smallest number that both 8 and 6 divide into evenly. 24 is the smallest number that 8 and 6 divide into evenly, which is necessary to get these. They need to divide in evenly so that you can get these equivalent fractions, right? The way you do this is 8 divides into 24 3 times. So 8 has to, whatever denominator you pick, 8 has to divide into it and 6 has to divide into it. So anyway, that least common multiple or least common denominator is the best denominator because it's the smallest one that both of the old or given denominators divide into. All right, folks, I hope this video has been useful. I hope it serves you well for the rest of your lives, or at least through your next math class, and we'll see you later.